Hi everyone. In today's challenge, we are going to solve this problem. The problem name is search in rotated sorted array, and the problem number is 33. Alright, guys. So first of all, what we are going to do, we are going to clearly understand the problem statement. After understanding the problem statement, then we will move to the logic part. And in the logic part, we are going to see how we can solve this problem. What is the logic we are going to use to solve this problem? So after understanding the logic part, then only we will move to the implementation part. And in the implementation part, we are going to implement our logic in Python, C++, Java, and JavaScript programming language. Fine guys, and guys, if you want to have a look on the solution which I'm gonna write in this video for Python, C++, Java and JavaScript programming language, I will share the link in the description. You can go through that particular link and you can find all the solution. Right now guys, let's see what this problem say. So let's understand the problem statement. So problem say there is an integer array, right? Num sorted in ascending order. So first of all, you know that guys, we are given one input, that is nothing but an array, right? So we are given one array that is sorted in ascending order, right? Fine. And always going to have a distinct value, right? There's no duplicate value present in our array. That makes sense. Prior to being passed to your function, num is nothing but an array, is possibly rotated and at an unknown pivot index, right? That pivot index will lie definitely from your array range, right? After that, such that the resulting array is nums of k plus 1, so on up to this. I'll tell you what is this. For example, let's take this example, right? 0 1 2 4 5 6 7. So this was the array which we have nums right now, right? But before passing to our function, before giving to us, what they have done, they have rotate this array at any index, like from this index or in this index, this index or this index, right? At any index they have rotated it. Now let's see, if they, let's assume this, they have rotated on this particular fourth index, right? So what will happen, this whole thing will come at the front, 4 5 6 7, and this thing will come after this. So after 7, 0 1 and 2. So now you can see guys, this is the rotated array, right, which has been rotated on this particular index, right? This 4 0 1 2 third index with this 4 value, right? So all these value will gonna come at front. So what happened actually, this value remains same here, but this whole thing come to the back side of it, right? So 0 1 and 2 is after the 7. So we can see now, now we can see 4 5 6 7 0 1 2. It is not in the sorted order now, but we know that earlier it was in sorted order, but just now they have just rotated at a fixed index, and now we are getting this particular array, right? So in the function we will have this array nums, not this previous array which is in sorted order, right? I hope it makes sense, right? Fine. Given the array nums, this nums array, after the possible rotations, after rotation, and an integer target. So that means that we are given one array and one target, right? So let me just tell you here. So one thing is our array, that is nums, right? That is clear now, which is going to be come after rotation. Second thing is nothing but an integer value, which is nothing but, we can say, target, right? This is target, this is nothing but an integer, right? Fine. Return the index of a target if it is in nums, or -1 it is not in the nums. Simple thing guys, you have learned or you have heard about a problem where we need to find a number from a array, that where we use a binary search, right? So here what we need to do, actually we need to actually do the same thing. We are given an array, we are given one target, we have to just find whether that target is present in our nums or not. If it is present in our array, nums array, so we have to return that index, on which index that number is present. If it is not present in that array, then we have to do, return -1, right? Simple thing. You must write an algorithm with big of log of and runtime complexity. So now we need to use a logic, we need to use an algorithm which should take not more than the go flow of and runtime complexity, right? Fine, so we have understood the problem. Let's see the example one. In example one, they are asking whether 0 is present in this nums array or not. If it is present, so return the index. You can see 0 is present at a 4 index. They have at a 4 index. But you can see this is not in a sorted order, right? This is in a, we can say, rotated order. So 4 5 6 7 is, after that we have 0 1 2, right? This should come earlier. Then it should be in sorted order, right? Fine, I hope it makes sense. So we have, but we have 0 in our this array, so we are going to return that particular index, which is 4. Now let's see, is 3 is present in this array? You can see in this array 3 is not present, so we are going to return nothing but -1, right? If 3 was present, then we have to return that index, otherwise we have to return -1. In the third example, you can see we have to find 0 in this one array, nums array, right? There also you can see 0 is not present, so we are going to return -1. Simple thing guys, if number is present, return that index, otherwise return -1, right? I hope this makes sense, right? So simple thing. Now let's see the logic part, how we can do this. So I hope problem statement is clear. Now let's see the logic, how we can solve this particular problem. So in the logic, I believe guys you know little bit binary search, because binary search is a very basic algorithm, right? and you should know it is a just basic algorithm. But let's see again what is binary search. So let's say this array is in our increasing order only. Increasing order you can say sorted order, right? So for 0 1 2 4 5 6 7, so this was our array, right? So if it is an array, so what you have to do, you are given a 0 as well, right? Target is 0, so you have to find a 0 from this array, right? So you can do find easily by using a binary search. So what actually binary search do, I'm just giving a little bit glimpse, not a whole thing. So you have low, right? So which is low is nothing but pointing to initially your starting index, and high is pointing to the end of the index. Then what you do, you find a mid is nothing but low plus high divided by 2, right? So after finding a mid, you will come here for, you will say this is my mid. So here you check if your mid, this value is equal to your target, then return this mid, because this is the correct index for my target, right? If it is not equal to our target, then what you are going to do, you can either move to the left side or right side. Why? Because this is sorted order, right? So we know if we are going to move to the left side, we will definitely move to the left side when our target is less than this mid value, then only we will move to the left side, right? Because it is in sorted order. But if we target is greater than our mid value, then we will move to the right side, because right side will always going to have more bigger, we can say greater value than mid, right? So if target is greater than 4, then it must be lie in the right side. If target is smaller than our mid, then it must be lie on the left side, right? And keep doing this. If you could not able to find your number of target, then you have to return -1. This is simple binary search, right? Just you can use implement this here, but you cannot use this particular algorithm over here, right? Why? Because it is not in a sorted order, right? Here we used to do, if it is greater, so move to the right side. If our target is smaller, then move to the left side. But here we can't do this because it isn't rotated. Then may be the case that here you can have, we can say what, we can say 9 and 10. This could be the case, right? So you know that for, let's say my target is 9, right? And you can see it is greater than 4. So with the previous logic, what we will do, we'll move to the right side, we'll move here. But it's not the case, right? 9 is greater than 4, I know, but it may be lying on the left side as well, right? Because you can see 9 and 10, because it is rotated, right? So what we can do, we can use a binary search, but with some condition. So now let's move to our problem. This is what the simple basic binary search problem. Now let's move to our problem, right? How we can use a binary search, because it is in order, right? So remember again, I'm telling, in previous video I have also tell, binary search is applied not only for sorted, it applies for the ordered, right? It applies for the ordered array, right? So whenever you find an array which is in ordered, it may be in sorted order, it may be in increasing order, or I can say it may be on modulus operator. Means there could be so many ways to make an array ordered, right? If you know the order, if you know that your array is ordered, then you can use a binary search over there, right? So let's see how we can use here. So I'm going to write simply this example, which is nothing but 4 5 6 7 0 and 1 and 2. So initially this is my nums array, right? Now focus here, this is going to be really critical part, right? Logic is always going to be a really critical part. This is low, this is high. That makes sense, right? So my range is now this much, low to high, right? Fine. Now what I'm going to do, I'm going to find a mid. Okay, I found a mid, and mid is nothing but, we can say, low plus high divided by 2, and low is initially 0 and high is initially, let's see, 1 2 3 4 5 6, high is 6, right? Fine, I found a mid. 0 plus 6 divided by 2 is nothing but 3. Mid is 3, and on 3 we have 7. This is my, let me take a different color. Why it's same thing? Fine, it is my mid. And we know target is nothing but 0, right? So target is nothing but 0. Fine. Now what we are going to do, we are going to not only check whether it is greater than or smaller than, move to the left or right side, right? No, we are not going to do this. We are going to say fine, first of all check, because let me show you one little thing. What was initially happening, this is 0, this is 1, this is 2, this is 4, this is 6, this is not 6. Okay, let me do this. This is 5, this is 6, and this is 7. So this was your array initially, right? It is in sorted order, but what happened, they have rotated it. So they have rotated this 5 6 7 and keep it on the front, right? So what I can do, I can say I had just all this front element, just do a little perpendicular. You can do like this, 0 1 2 and 4, right? So I have can remove this one here. So what they have done, like this, right? So initially this whole thing was lying over here, but what happened, they have rotated it. 5 6 7 remain here, and 0 1 2 4 remain after this, right? It happened after this. So now I can remove this perpendicular as well. So I hope guys know, now you understood that how the structure has been broken, right? Our array is broken like this. So we have a sorted order in two ways. This is also in sorted order, right? So this is also in sorted order. This is also in sorted order. This is gonna give us a benefit, right? So both are in sorted order, but they are not in order now. The first you are adding this value, then you are getting in this value. So they have broken down to a two part. Now let's see how we can use this graph, right? So what I'm gonna do, I'm gonna say I found a mid which is nothing but 7, right? My target is 0, right? My target is nothing but we can say 0. So where should I move? I should move to the left side or right side, right? We can only move to the left or right side, right? So either I can move to the left side or right side. So the first condition which we are going to check, we are going to check initially if this is like in this first graph or this is the second graph. So how we can check if it is first graph or second graph, right? So to check this part, what we can do, we can say if simply if this mid value is greater than the low value, no. If it is mid value is greater than low value, then definitely it will be lying on the first graph, right? I hope it makes sense. If it is not, if it is this mid value is not greater than the this low value, then it is lying on the second graph. So for example, now you can see 7 which is less than or which is greater than 4. So what we can say, this is lying on the first graph. That means this is in this, you can see 5 6 7, and there should be 4 right as well. So I have done a 4 here, and I can move 0 from here, right? Fine. So what I'm gonna do here, I'm gonna say fine, I got this in my first graph. I understood this part, right? I know this in my first graph. Now tell me whether we should move to the left or right side. So one thing we know that now, if it is in first graph, I can say all the values which is before this 7 is always gonna be less than 7. Getting this point? The thing is nothing but, as you know, this is in first graph, so we know all the value which is before this 7, which before this mid, always gonna be less than 7. It makes sense, right? But after this 7, we don't guarantee that it is always be greater than or smaller than, right? But before this 7, we're always gonna have all the value which is in less than 7, right? So now what we are going to, we know that our target, now we are going to check our target, is it greater than 7 or smaller than 7? As you know that target is smaller than 7, right? So it is smaller than 7. So what we can do, we can say either it can move, if it is smaller than 7. So we know that, just also check one more thing. Target is smaller than 7, target is, we can say, less than mid. Fine. And is target is greater than low or not, right? So if your target is greater than low or not, so we can say if target is greater than low, so we are going to get some range which is going to be lying between this. But you can see here target is not also greater than low, it is also less than our low. Target is 0, low is 4, so target is also less than 4. So we know that, guys, this complete range, it will not gonna lie. Why? It is also less than this mid, it is also less than this 4, right? Right. So we can say it always be lying on the right side, so we are going to say move to the right side. So you have seen one condition. First is nothing but if target is less than mid, if target is less than mid, and inside this condition, if your target is also less than your low, so you are going to move to the right side, right? Else, if it is not the case, you are going to move to the left side only. And if this bigger else, if target is not less than mid, it is greater than mid, right? If it is greater than mid, so what you are going to do, you are going to say directly move to the right side. Why? Because all the numbers are lying on the left, smaller, right, on the left side. From this mid, all the number are less than 7 on the left side. But if target is your greater, so definitely it will be lying on the right side. So we have seen this condition, right? Let me move all these things. So we have seen these two conditions, right? First is if target is less than mid, so check it whether it is less than low or not. If it is also less than low, so it is going to be on right side. If it is not less than low, it is going to be moved to the right side. So we are going to move to the right side, right? Okay, not right. It is also be less than right. So if target is less than mid, right? If it is greater than mid, so we are going to move to the right. Fine, which makes sense. So fine. Now what we are going to do, we are going to say simply. Let's me just quickly go through here. So we are know that we are at mid. We found out that 3 is not greater than 3 is this mid. Our target, we can say target is 0. It is not greater than mid. So we are check it is also less than this low. So we are going to move to the right side. So our low is going to be now here, right? So we can move this low here, and we can say low is here, and high is there, right? High is here. Now the mid is going to be nothing but 4 plus 6. We can say 10 divided by 2 5. So mid is nothing but at here, right? Mid is at here. So what we can say now, our mid is here at 5, and we know that it is lying in the first quadrant, and in that we can say it is target is nothing but now this time target is great. Also we can say great, less than mid only, right? Target is also less than mid, but here target is greater than or equal to low. So this condition will not satisfy, right? Target is not less than low, it is greater than or equal to low, right? So target is nothing but greater than equal to low. So we can say okay, so move to the where side, left side, right? So move to the this side, move to the we can say left side. So it is going to be nothing but high is going to be like here. Now high and low point to the same index. So low plus high divided by 2, which in other words we can say 4 only. So 4 plus 4 divided by 2 is 4 only. And at 4 you will find your mid, and mid is also equal to target. So you are going to return nothing but 4 only. I know this is quite complex, but now let's summarize this one whole thing. So what I'm going to say, first of all check if your target is less than mid or not. If this is for first quadrant, right? If it is less than mid, fine, then you are going to move to the this. But first of all, let's write here first condition. If your nums of low is less than your target, is less than your nums of mid, right? That means nothing but it is lying in the first quadrant, right? If nums of low is less than or equal to your mid, so it is in first quadrant, else it is in the second quadrant, otherwise in the first quadrant, right? That is clear, right? Now let's see the second pass. If it is in first quadrant, so what we are going to do? We are going to simply say if our target is smaller than our mid, that means if a target is smaller than mid, that means there is a possibility that it will always be on the left side. It could be because all the values on the left side are smaller than we can say our mid, right? So we are going to say inside of this condition, if our target is also if target is greater than low or equal to low, target is greater than or equal to low. If it is greater than this 4, right? If it is greater than or equal to this 4, that means it is in between of this, right? Target is smaller than this 7, but is greater than or equal to 4. That means it always lie in this range. So we are going to say you move to the left side, otherwise else move to the right side, and in this bigger else also you have to move to the right side. And why? Because if target is greater than mid, then definitely it will be on the right side, because all the values on the left side are smaller than target, right? Same thing you have to do for the we can say second quadrant. But you can say if your target is greater than mid, so it will always be on the right side, but right, if it is greater, not always be, if it is greater than mid, so what we can say, if it is greater than mid, so we can say on the mid side all the values are greater than target, right? But if it is second quadrant, right? So what we can do, okay, fine. If it is greater than mid, just check it. If your target is also greater than your high, then you have to move to the on which side? Only you have to move to the on left side, right? But if it is less than or equal to high, then you have to say, if it is less than or equal to high, then you can say just move to the right side. Else you have to move to the left side. Else in this bigger else also you have to move to the left side. So this is the simple logic, guys. I hope it makes sense. It's just quite confusing, but if we go through this particular part, you find two phase here, right? The first is first quadrant where all the values are increasing order. Second quadrant also where all the values are increasing order. But the second quadrant is smaller than this first one, right? I hope it makes sense. So if your value mid is lying on the first quadrant, that you are sure that all the values on the left side is always be less than your mid. But if your target is, mid is lying on the second quadrant, then you are only sure that your right side will always be greater than, your right side will always be greater than your mid, but left side there is no guarantee. So same thing we are doing, just we are taking the benefit of this. If lying in the first quadrant, we know that left side always be smaller than mid. So we are checking if our target is in this range. If it is in this range, so move to this side, otherwise move to the right side. Same thing for the second quadrant. If our second quadrant lie in this range, then we are checking whether our target is present in this range or not. If it is present, so move to the right side, but otherwise we can say move to the left side only. So same thing, just move to the, let's move to the implementation part. Let's see how we can implement this one, right? So I'm just first of all with a Python, and here first of all what I'm going to do, I'm going to find a mid. Before that, low is range, low is nothing but, and high, low is 0, high nothing but length of nums minus 1. Fine. After finding a range, we are going to say while low is less than or equal to high, and we can say find a mid, low plus high divided by 2. And here we can say if our nums of mid is equal to target. So what we can say, simply return. And what we can say, we can simply return our mid, right? We found target. But if we note, so we are going to check whether it is in first quadrant or second. If nums of mid is greater than or equal to our nums of low, that means it is in a first quadrant. If it is first quadrant, we are going to check if nums of mid is our greater than target. It is we can say if it is smaller than target, right? If it nums of mid is smaller than target, that means nothing but we have some number on the left side which is less than mid, so it may be from their from this number, right? So we can say okay, if this nums of low is greater than or equal to, right? If it is greater than or equal to target, that means it is now on the left side only, so we can say move to the left side. So we can say I should be equal to mid minus 1, right? Let's rephrase it. So first of all, we are checking whether it is first quadrant or no. If it is first quadrant, so that means nums of mid is greater than or equal to nums of low. Now checking if nums of mid, the middle value is greater than target or smaller than target. If it is smaller than target, then there may be possibility that it may lie on the left side. Okay, if it is now let's see the low part. If nums of flow is greater than equal to target, nums of flow is greater than equal to target, that means now it is sure that it is on the left side only, so we move to the left side. Else, in this inside else we are going to find, so we can say okay, if it is not the case, if nums of flow is not greater than equal to target, so it will be on the right side only, else it is going to be mid plus 1, and also in this bigger else as well we can say it's going to be on the right side. Fine. Now this whole else means now we are on the second quadrant. We are going to say fine, if nums of mid is we can say greater than target, right? Nums of mid is greater than target is fine. If it is greater than target, what we can do? If nums of mid is greater than target, right? So we can say here we have done some mistake. Nums of mid should be greater than target, right? Then only we can do, right? If nums of mid is greater than target, so we can say nums of flow should also be greater than target, right? If nums of in here, if it is smaller than target, right? Nums of mid is smaller than target. Now what we can say, if it is smaller than target, that means target is greater than mid, right? So it may be lying on the right side. If it is lying on the right side, so what we can say, check it. If nums of high, is it also greater than target? If it is also greater than target, nums of mid is greater than target, that means that the target is smaller than mid, right? So what I am doing is I am getting again rows here. So if we do this part, so what we are going to happen, let's move to this part, right? So I get confused. So 7 mid, right? Now if we are at mid, so what we are checking, whether it is greater than target or less than target, right? So we are saying that if nums of mid, which is point of 7, 7 is less than 0, right? Greater than 0, right? So if 7 is less than 0, it is not going to possible, right? So if 7 is, if nums of mid is greater than only, right? If nums of mid is greater than target, then it's fine, target is smaller. But here if nums of mid is smaller than target, right? Now we are going to say fine, now let's for high as well. If nums of high is also smaller than target, then what we can say, let's put equal to as well. Then we can simply say our we should move to the right side, right? So we can say for moving the right side, low is going to be nothing but mid plus 1, else we can say high should be mid minus 1, and else we can say high should be mid minus 1, right? And then we can say simply, if you are coming out from this while loop, you can simply return minus 1. Now let's see whether it's working fine or not. So I think it should work, right? Let's see whether we have done any mistake. Yeah, we have done. We see returning a minus 1, but it should not return this, right? So if nums of mid is equal to target, so return mid. If nums of mid in lie in the first quadrant, where nums of mid is always going to be greater than our nums of low, then we are going to check if nums of mid is equal to target, is greater than target. So yeah, it is greater than target. Then what we are going to do? We are going to say if target is smaller than mid, so it always it may be the chance that it lying on the left side, right? So we can say if nums of low is also greater than equal to target. No, if nums of flow is smaller, right? Nums of flow is smaller than equal to target, so it should be high is equal to mid minus 1, otherwise low is equal to mid plus 1, right? Now let's see whether it's working fine or not. And here also we can say nums of high, right? Now let's see. You can see all the test case passed, so let's try to submit this. I know it's quite confusing, guys, right? But for now, just I can give a little hint. Just try to use a different array, because with this only one array, we could not able to find all the cases. But yeah, this is going to be the case, right? You can see, guys, it successfully got accepted. Now let's move to the next programming language, which is C++. So now here what we are going to do, we are going to say low, which is nothing but 0, and high, which we can say nums of size minus 1. We can say while low is less than equal to high, we can say keep our we can say minus such. So here we can say find a mid, low plus high, we can say divide by 1, divide by 2. Once we divide by 2, we are going to say if our mid, if nums of mid is equal to target, so we can say find, we found out our target, so we can say return that mid. But if it is not the case, so we are going to say if nums of mid is yes, greater than or equal to nums of low, that means it is in the first quadrant. So we can say if nums of mid is greater than, if it is greater than our number target, it's fine. After that we can say if it is greater than target. Now let's move to the next condition. If our nums of low, if it is we can say smaller than our target or equal to our target, so what we can say move to the left side. So low is going to be nothing but mid minus 1. Not, this is not on the left side. High is equal to mid minus 1, right? Else we can say low is going to be as well mid plus 1, right? And this else as well we can say low is going to be mid plus 1, right? Fine. After this, if we can say else, this in second quadrant, if nums of mid is we can say smaller than our target, and if nums of high, we can say if it is high is greater than equal to target, so we can say this is on the first quadrant. So we can find on the second we can say on the right side, so move to the right side. For that we can say low should be equal to mid plus 1. But if it is not the case, so we can say I should be mid minus 1, because we are moving to the left side now. And the else condition as well, high should be mid minus 1, right? Fine. After this, what we can say at the end, return minus 1 if we could not find our target, right? Let's see whether it's fine or no. So I think it should work, right? Let's see. We got an error because we did not put a semicolon here. Okay, let's run again. And taking a time, but I think it should pass. You can see, guys, all the tasks is passed. So let's try to submit this code. It's fine. It's taking a time. You can see, guys, it successfully got accepted. Now let's move to the next programming language, which in nothing but we can say Java. And in the Java, first of all, we are going to take a low. Int low is going to 0, and high is equal to we can say nums dot length minus 1. Once we found this, we are going to use a binary search while low is less than equal to high. So we are going to say what? We are going to find a mid, low plus high, plus high divided by 1 divided by 2. After that, we can say fine. Now check with this, it is in first quadrant or second. If mid is equal to nums not mid, we can say first of all check whether it is equal to target or not. So if nums of mid is equal to target, so we are going to simply say return our mid. We found a target. But if it is not the case, so check if it is first quadrant or second. If nums of mid is greater than equal to nums of low, it is in first quadrant. Right, so we can say fine. Now we are going to check if nums of mid. If nums of mid is greater than target, that means our target is smaller than that. So fine. Now let's we can say like fine. Now we are going to say if nums of mid, no not mid, nums of low is greater than or equal to our target, then we can say finally definitely it will be present in the left side only, right? If it is present in the left side, so we can say high should be mid minus 1. We move to the left side. But if it is not the case, low should be mid plus 1. And same thing on here. Else condition, low should be mid plus 1, right? Move to the right side. Fine. If it is not in the first quadrant, it is second quadrant, then what we will do? We will say we know in the second quadrant all the numbers on the right side will always be greater than the mid. If nums of mid is we can say smaller than target, the target is greater, so it will always, it may be the chance that it will be lying on the right side. So we can say fine. Now check if nums of high, let me put square bracket here, if nums of high is greater than or equal to our target, then we can say it is lying on the right side only, right? So we can say move to the right side, low is equal to mid plus 1. But otherwise it is not the case, move to the right left side, low high is equal to mid minus 1. And else high is equal to what we have used, this high is equal to mid minus 1. And then we can say what we can say return minus 1 if we could not find our target. Now let's see whether this working fine or not. So we got an error, right? It's saying that minus 1. So we have done some mistake over here. Let's find out whether we have what thing we have missed, right? So if nums of mid is greater than equal to low, right? If nums of mid is greater than equal to low, this is in the first quadrant, fine. If nums of mid is greater than target, if it is greater than target, that means our target is smaller. So it may be the case that it's lying on the left side, so we are going to say fine. Now let's see if nums of low is not greater than, it should be smaller, right? Fine. Now let's see. You can see, guys, all the rest is passed. So let's try to submit this code and it will get submitted. Now let's move to the next programming language. You can see it's accepted. Now let's move to the JavaScript. And here we are going to say fine. And let low is equal to 0, high is equal to nums dot size. We can say length and we can say minus 1. Fine. After this, what we can say fine, use a binary search while low is less than equal to high. Find a mid is going to be low plus high, divide by 2. After that, check whether it is equal to target or no. If nums of mid is equal to target, so we can simply say return mid. But if it is not the case, so we are going to say fine, check it is in first quadrant or not. If nums of mid is greater than equal to nums of low, it is in the first quadrant, so we are going to fine. Now check it if it is lying the left side or right side. If it is in the nums of mid is greater than target, and if nums of mid, we can say if nums of mid, let me write in nums. If nums of low is greater than or equal to target, so that means it is lying on the left side. So we can say move to the left side. So how we can do? We can simply say high should be mid minus 1. But if it is not the case, then move to the right side. For right side, we can say low is equal to mid plus 1. And same goes for here, low is equal to mid plus 1. And same in this second quadrant, we can say else if our nums of mid is we can say smaller than target is greater, so there may be chance that it lies on the right side. So we can say if nums of high is greater than or equal to our target, then we can say it is lying on the right side. So move to the right side. No is equal to mid plus 1. Else we can say high is equal to mid minus 1. Move to the left side. And this bigger as well. We can say high is equal to mid minus 1. And then we can say return minus 1 if it is not able to find out, right? Now let's see whether this we can find or no. And we got an error again. It's saying minus 1. Again we have done some mistake. Let's see. Fine, it's fine. So here the same thing again. If lumps of flow is smaller than, right? Let's see now. It should work, right? I hope it should work. You can see all the task is passed, so let's try to submit this code. And by this, if it gets submitted, right? Let's see. And you can see, guys, it successfully got submitted. So now we have done the implementation of Python, C++, Java, and JavaScript programming language. And guys, if you have any kind of doubt in the problem understanding part, logic part, or implementation part, you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.